Yep, sounds like we're live. So welcome back, everybody. I think one of the things that was kind of effective last week was to try to give the big picture occasionally, and Dudley went through a lot of stuff and gave a lot of detail, but he also gave the big picture, and I was worried that maybe people lost it a little bit, so I wanted to reiterate and just, tell me if I'm going off base here. But these models are really interesting because what Dudley is doing is developing relationships between the amount of flow in these systems and the amount of habitat that's available for fish, and both in the short term and long term, with an eye toward figuring out if a mine project would change the amount of flow in a system, what would be the effect on the amount of habitat available. So this is kind of a really interesting section of the environmental baseline document. Did I miss anything there, Dudley?
No, that's correct. Right.
All right.
And not only the habitat from the spatial perspective, but also water temperature I mentioned and channel form. And
Yeah. So.
Channel habitat before.
Yeah. So Dudley, just for those of you that couldn't hear, he said that his modeling also included off-channel habitat, channel forming, water temperature, all these other aspects of habitat for fish. So next on the agenda, we're going to have a discussion between Dudley Reiser and our panel members, and we're going to start off. Mike Stone has been kind of assigned the lead for the panel in evaluating this section of the environmental baseline document, and he's got a few PowerPoints to illustrate some of his comments and questions, so he's going to do that first, and then we'll bring the whole panel up for discussion. So, Mike?
Okay. How do I get this to show on this?
That is not in your control.
Okay.
Somebody else will turn on the overhead projector.
Okay. This won't be a pretty PowerPoint presentation. Late last week, Milo indicated that at last week's panel, some people had outlined some of their talking points, and that might be helpful. And so I quick put a few things together, and it'll be helpful to keep me on track as well. It's divided up in three sections. First, I'd like to talk a little bit about the context of our review. You know, that's something I struggle with, and I think some of the others, and I think the public's probably struggled with as well. Next, I have just a few observations on the aquatic habitat and in-stream flow studies, and then some comments, kind of a critique, and a few questions. And I can run through those, and maybe they can serve for some discussion later on with the consultants. First was the purpose of our independent science panel review. And it's to review the environmental baseline documents. That was really the charge, and ask whether it characterizes the existing environment. And that's kind of an open-ended question, and it's somewhat in the eye of the beholder. To characterize to some means answer every possible scientific question. To others, it may be just give me an idea of what's going on here, or something in between. So that's a thing to struggle with. Also, the part of the purpose was to make recommendations for improvement, do a constructive critique. Whoops, wrong way. The scope, I think this is just maybe more important, is that it's not an evaluation of any development proposal. It's not an evaluation of impacts. Had I looked, and I suspect the other panelists looked at these studies with respect to analyzing impacts, we'd have a totally different analysis than we would of a characterization of the existing environment. We were limited to the study area provided. We didn't have any opportunity to go beyond what was provided in the baseline documents. And the study period is limited to that period 2004 to 2008. We did not have any subsequent information like was presented of what's ongoing. So with the limitations, you may come to the question of, so why bother? And I think there's two reasons for that. One of them is the importance of the description of the affected environment in a NEPA process or document. Just looking from some of environmental documents I've worked with and processes in my former job, when a proposal came up, any kind of a proposal, we spent a lot of time providing information to consultants, project proponents, of what information our agency had in that area relative to the resources under our responsibility. We had, often we had documents, databases, whatever information. So it wasn't all things that they studied on their own. And our agencies and agencies throughout the West are continuing to put together databases on various topics, whether it's from sage-grouse areas to migration corridors for terrestrial species, with the idea that it's really important in the NEPA process, National Environmental Policy Act process that leads the environmental impact statements relate to have the resources described in that section of the document. If they aren't described there, you can't expect the impacts to those resources to be covered. So it's critical if something's important, it's described in there at least. But that's different from the impacts and mitigation aspects later on. Also, as part of the independent science panel public dialogue that I think Todd has talked about, it's important from that aspect to hopefully give people a better feel for the characterization of those baseline documents. Some observations on the aquatic habitat surveys. It was mentioned that the Forest Service Aquatic Habitat Management Handbook served as a basis for many of those. There are several methods you could use to characterize habitats. That's one that's been peer reviewed. It's used widely. The Forest Service has a cadre of scientists that review those types of procedures before they go into the handbook, and it captures many of the basic habitat features that you'd want to capture. So that seems to be an appropriate approach. It also has different tiers, from tier 1 from a reach type categorizing, a broad brush thing, down to more specifics in tier 3. They looked at the main stem, the tributaries, and off channel, which is important. There was field surveys done and mapping from remote sensing. As was mentioned, that this seems to be an area that lends itself well to the remote sensing and photography. As mentioned, the uniformity from just the brief chance that we had to visit parts of the study areas. One of the things that impressed me immediately flying over there was it was much different than I expected. It was much more uniform, and you could see it, and you could see to the bottom of it, and it wasn't obstructed by vegetation. So easy for remote sensing. And using GIS, quantified the distribution and total area of habitat types for each reach. So I think from that aspect, that was helpful in characterizing those resources. The in-stream flow studies, Dudley mentioned the in-stream flow incremental methodology was used in physical habitat simulation. Again, there are a variety of techniques that you can use. These two methods have been around since they were developed in the late 70s and early 80s, and they've withstood, I think, quite a bit of test of time and scrutiny. There's certainly limitations to them, but they do offer something that many of the other methods don't, and that's that they're able to quantify that weighted usable area at various flows and time series, that incremental aspect that you don't get when you get a method that says we recommend flow X or Y. This incremental aspect and the ability to essentially map out and quantify weighted usable area. So from that perspective, that's quite useful. They also incorporated the surface water temperatures, monitoring models. That's quite important, and some studies don't do that, but this one did. The aspects of fluvial geomorphology, surface and groundwater hydrology, and spawning gravel quality. That's the last things I think that were covered in Dudley's presentation. That those are very important, and particularly in the types of geology and groundwater, that it's important to include those in this baseline study. And as you heard, this spawning gravel quality is very high there. The habitat suitability criteria were done not only from the literature but also with field data. I know there's people get hung up at times on those curves, but there's a range within those curves. It's not an infinite array that provides good habitat. So you really can kind of hone in on what the suitable spawning conditions are, for example. And there was extensive data collection and analysis. I've not done very many. We've worked on a couple of very initial runs for the in-stream flow modeling when it was still being developed, and they were using punch cards down there with the in-stream flow group at Fort Collins at the time. But I've had crews that have worked on that continually since, and I know that the data collection for this type of thing is extensive. The analysis is extensive, and I didn't count the pages, but I think there's probably well over 1,000 of those pages in the document that are pieces of the analysis that allow you to go in and see if the flow calibration was done properly or not. And so I guess the point of all that is that that's an extensive and massive amount of work, and it's, at least from my quick review, is transparent that you can go in and check and see for some of those key places that you might have errors, that others can go in later and look at those, that those curves and ratings are in there for you. Comments. The in-stream flow characterization is strongly dependent on hydrology and fisheries data, and that's both the surface and the groundwater hydrology. You can map out the hydraulics of a stream, map out what might be potential habitat, but until you factor in the hydrology and the fisheries data, you really don't have much. You've got kind of theory out there. You've got the hydraulics, but you don't have what it really means. So as far as comments, if the environmental analysis proceeds, I think that's important to continue to have an interaction between updates in the hydrology and fisheries data that tie in with the in-stream flow. There were a few USGS gauges, and it sounded like even fewer that had been around very long. So the gauging is short-term out there. That's a concern to me, simply because we see that short-term gauges are a snapshot. Short-term measurement of about anything in nature is a snapshot, and that over a period of 50 years, 100, several hundred years, you can have a different picture. I'll use an example in the Colorado River drainage. That's certainly different, but the folks there that deal with the paleontological records and some of the tree ring work have found, going back, that the period that we settled that part of the country and developed water, the past 100, 150 years, was one of the driest, or excuse me, one of the wettest periods in several hundred years. So if we're taking a snapshot here, are we looking at a period of record that's all in a high water period, in a low water period, something in between? So for that, from that perspective, I think that's a real key part of any of the water-related issues. The simulations for ungauged streams, that was necessary because that there was not a long record. And from reading the little bit of the hydrology chapter, it sounded like, and I may have this wrong, but it sounded like that those 68 years or 62 years of record were largely simulated from 2004 through 2008, plus if there were any other USGS gauges around. So that's a limitation. Also, with the lack of gauges around there, I think that the simulation analysis didn't reflect accurately on some of the peak flows, and there was a recognition that that really didn't fit with the characteristics out here real closely. And we see that in other areas. Sometimes those simulations work quite well. Sometimes they don't work quite so well, and particularly depending if you're looking at a small tributary or a grosser scale. And I would expect with the complex groundwater hydrology that we have, and where you saw the groundwater transfer from one drainage to another, that would certainly be a complication for some sort of estimating technique on non-gauge. So that puts the categorization of the average wet and dry conditions for the in-stream flow analysis, I think, into I put quotes around those wet, average, and dry, that with a longer period of record and maybe a little better idea of what a dry or wet condition is, you might adjust those differently. And I think finally here, and I saw that Dudley led right into that, but we haven't, just looking at 2004 to 2008, that wasn't done. It's, I think, really key as this proceeds on, if it, for any environmental analysis, and particularly if there's going to be any impact assessment or monitoring, to integrate that channel of geomorphology and hydrology with the in-stream flow to get a whole systems approach. And conceivably, and we've seen this on some of the regulated watersheds and other places, that you could have a flow that pretty much maximizes that weighted usable area for a life stage in the stream. But over time, if there's not some sort of channel forming or channel maintenance events, that you could be maximizing a decreasing amount of habitat in that stream. So you may not always go for that maximum weighted usable area. And it's complex, but I think the integration for a systems approach, so you maintain the system and the flows within that system for the perpetuation of fish. Questions? I guess I gave one of these away already. The question of general deposit location versus mine study area, and that was answered. The experience level of crews, and a little bit of that was answered, I think, by Dudley, where he mentioned that they have hydraulic specialists to do that. I know we, and I think others with in-stream flow crews, have found that there's a difference in what's an experienced person with in-stream flow methodologies, and I'd still kind of have that question for Dudley later on here of going out and helping on a crew with the surveying and the stream measurements for summer. That's experienced, but people who run it from top to bottom for a year usually don't think they're experienced yet, and it takes a couple of years, and particularly with that hydraulic calibration, that it's something that there's a learning curve to it. So I'd be curious on both for the habitat measurements for the with the Forest Service method and the in-stream flow, of the level of experience that people have. And then finally, and this may have been out of the scope of what you folks were asked to do with your study, but often in description of the affected environment, it doesn't just go with the studies that were conducted. It uses other sources of information, and I don't know if there were, for example, if the Alaska Department of Fish and Game has conducted in-stream flow studies up there. They have filings on this. Are there other habitat studies that are available that should be pulled in at some time? And are there are there other sources of traditional or native information? Just are there, for example, was that intermittent section always that way, or are there people around that remember that after a seismic event that it changed, or after a period of really high water years for a decade that it flowed continually for another 4 years during the lower flow periods and that type of thing. So there may or may not be any information available there, but that's something that I didn't see in these studies. So that's really all I have.
All right, thanks, Mike. Yes, let's go ahead and get the panel members and Dudley up front here. And the way we've been doing this is when we do have a panel member that comes up and does sort of an overall impressions talk like that, I'd like to start with giving Dudley an opportunity to respond to some of the comments that Mike made.
The ones that struck me, I think, Mike, your comments on I'll go from the most recent back, and the level of experience, I guess I'll talk to that issue first, of the crews that we've had working on this project. I can only speak to the level that our company has been involved in. We started in 2008. So 2008, the work that we did was led by, actually the field crews were led by two PhD level engineers, actually, that have been involved in in-stream flow studies for probably 20, 25 years. So those individuals with their field crews were out collecting the data. I mean, they know the process from the top down all the way to the modeling. They're both hydraulic engineers, so they've got that understanding of how to calibrate the models. And I guess I'm a biologist, so I leave that sort of thing to them when they get into the calibration part, because I know they have a better understanding of hydraulics in that process. So the field crews and the process that we have as a company, we've sort of specialized in in-stream flow studies generally, and have been doing that work for, since the company started in 20 years ago, and then beyond that, a lot of us work together beyond that. So I think we've got a really good handle on that. I would say the work that was done by the other consultant, I really don't know. I'd have to go in and look at the people, actually the staff that were collecting the data. I know that the person that was in charge of that also had his PE engineering degree and had been involved in in-stream flow studies a number of years. Beyond that, it was upon R2 to take a review of all the information that were provided to us from 2004 to 2007 that we didn't collect, and subject that to QA, QC, and then we've selected through that, and that was the reason that we went in and collected additional data. So I think the data that we've used to develop the models that we have gone through a very rigorous review. Any new data that's been collected we feel very confident about, and the hydraulic modeling parts we feel very confident about as well. So hopefully that addresses that aspect. The other one that came to mind was the hydrology part, and I'm not the hydrologist that has been working on that. That is Knight Piesel, Jamie Cathcart. And you mentioned that you did review, at least partially, the hydrology section in there. And we've had numerous discussions with Jamie, and the level of detail that they've put into the simulations has been extensive. If you've talked to Jamie and you sort of get a perspective of projects that he's worked on where they have a network of gauges that they've installed and applied, this Pebble project stands out way and above any other project that he's worked on, if I'm characterizing that correctly, in the sense of the density of gauges that they put in. Now, granted, they're short term, but the point is that they are trying to, we're trying to understand the hydrology at different locations, and then it always is a challenge. I mean, Alaska is very difficult in the sense of it's so massive, extensive, that there are relatively few gauges throughout the state. They're expensive to man, expensive, understandably, the USGS has a finite budget. It's unfortunate that there aren't more gauges, but I think they've probably done a very admirable job in looking at the simulations. Having said that, I agree with you, though. I think there's still room for considering different scenarios that might lead you to think of different average year types, water year types, or different wet year types. So that's something that I'm very much open and acknowledge that it's not like that's the only answer, but I think that they've got a very good data set pulled together that we've used in developing the models that we have. I can't remember if there were other specific points.
And Mike, if you're going to say something, we've had comments from the TV people and also numerous comments from the web participants that they really appreciate it when you guys pull the mic close to you before you speak.
I think those were the, let's see, questions. Back on the, where were you? Just to refresh on that section of the comments, one was on the dependency of the in-stream flow studies on the complex hydrology and fisheries data that I think you recognize, then the gauges. And then the final one in that section was integrating the channel geomorphology and hydrology into systems. That the study led up to that, but that's a huge issue to get a systems recommendation to maintain channels and all that. That wasn't completed in that 2004 and 8, and you alluded to some ongoing things there.
Right. No, that's a good point, and I did touch on that as the last sort of parting shot, if you will, where I was talking about the combination of different in-stream flow elements that we're dealing with. The reality on that aspect is that there's been substantial work done leading up to and including the EBD work that you've reviewed. We're now in the process of considering that further, and so I did not present any additional analyses on it. And suffice it to say that it's recognized that that's an important aspect of it. Anytime we're dealing with in-stream flow issues, whether it's a hydro project or any water resource development, as Mike alludes to, back in the olden days, if you will, the concept of minimum flows was one that was used, and that simply talked about once the single flow, the absolute minimum that you can release. Well, that doesn't hold anymore. There's been the normative river concept that has been brought forward. There's Nature Conservancy has developed an IHA process, indicators of hydrologic alteration, that is oftentimes used in evaluating projects. There's just a worldwide recognition that you don't want to come up with just a single flow, even for a single month, or separate months. It's more holistic, system-wide, where you've got to look at all the other components, including riparian. I mean, one thing that we didn't talk about is riparian. Riparian community structure is also in part of the equation. So those are things that are being looked at and considered, and I'm sure down the road there'll be further refinements of that.
Do you have more, Mike?
There was one other one I think I skipped over in the slides, and that was in-stream flow consultants noticed that one company started and your company finished this, I think 1 year and maybe a little more, and I'm not sure why, but you covered the quality control transition there, I think, in the documents quite well, where you'd analyze the transects and all that, but your last year you went in a different direction, and I don't know if that's because of the pre-planned study design, or the question I had for you is if you were starting it from start to finish with one company, with your company, would there be changes in direction that you, or would have been organized differently?
That's a good question. You know, as a scientist, you use information that you have available. I tend to be a person that looks at all information and data and simply don't disregard any of it. I think the prior consultants, if you look at the methodologies that they applied in selecting sites to begin with, they're consistent with how we would have gone about it to begin with, which is to start off with a reconnaissance level approach of actually identifying the different habitat types that are out there, and then coming up in the subsequent years they came in with the stratified random approach of wanting to make sure that you capture the different habitat features that are in there and you put transects located in those other in representative areas that are present. If we had started it, I mean, there's it's a possibility that there would have been different approach that we might have taken in certain aspects of it. When we came in, one of the first tasks was to evaluate the robustness of those data, the QA/QC of those data, which we did, and it took some time. And we gleaned out areas, transects, if you will, that were problematic. We even as I mentioned in the slides there, we ended up identifying even late in the game another 20-some transects that we thought wouldn't pass muster in terms of calibrations. And so we elected to go out and collect additional data on those sites. Those data sets, that doesn't mean that the data sets that were collected before were not worthwhile. There's still data that's information, but it's just we felt like for those particular locations, and I'll give you an example of the situation where we might recommend and actually do that. If you've been involved in this type of work for a number of years, and I'm sure, Mike, you relate to this, if you collect transect data over different flow conditions, and you've collected 2 sets of flow measurements on a channel profile that is pretty much the same, because you haven't gone through a whole runoff cycle. For whatever reason, the 3rd set comes in and it was postponed until the following year, and it's post-runoff, and you get back to that same location, and there's been channel bed movement, so that the calibration process of actually being able to develop a hydraulic model associated with that location becomes very problematic. So in those cases, those types of situations would be where we would recommend, well, let's just start over and get a complete clean data set all within 1 year, so that we aren't faced with that sort of situation. Now, the other part of when we came in to the analysis, so we had the 92 transects that were located in different, within representative areas. If you start thinking about in-stream flow studies, sometimes you might get into what you might call critical areas, or areas that are biologically important, and you want to focus in on some of those. As part of the process, in 2008, we had dialogue going on with what was called the TWG process at that time with agencies. We had interaction with State Fish and Game, ADF&G, and Fish and Wildlife Service, and in consult we had an in-stream flow group, and we had laid out what our thoughts were, how we were proceeding with the QA/QC of the other data, and the notion of, well, maybe rather than being extensive in the sampling, in covering all of these different locations, what about being intensive on a smaller subset of those, so that your transects are located in higher densities? They're not so spread out. So that was the discussion that transpired during those meetings, and that was how we approached the 2008. Actually went out in the field with agency, with ADF&G participation, and identified locations up and down, tentative sites, and then concentrated on those areas so that we could work an entire site instead of having a transect located here and 2 miles away another transect. We had them all within a relatively short area to see if those flow responses would be any different than what we would have at the more widely spaced transects. So there was, we sort of built on different approaches. The early on was stratified random, making sure we had reaches covered and we had representation of all the, of what we consider to be the different habitat features in there. And then in 2008, going in and doing a little bit more focused study on certain locations. So I don't know if I answered your question. That was a long-winded response.
Anything else, Mike?
Well, I was looking around at what Dudley had answered here before that. Other sources of information, is that something that was beyond the scope of your guys' work? Or is there information from other agencies on in-stream flows or anything that's happened in those habitats, observations, or is that something you didn't look at all?
Well, for that particular location, I would say the most reliable data source was the existing work that we reviewed, the work that HDR had completed. I don't recall there being any specific in-stream flow studies done on any of those streams at that location. However, there's a lot of in-stream flow studies that have been done in the state of Alaska. There's work that we have done in the state of Alaska where you end up compiling suitability criteria, for example, looking at life history information, there's extensive amounts of information on species characteristics and life histories of Alaska anadromous fishes and resident fishes. So we relied on that. And we relied on a lot of other information too that we've pulled together over the years on types of pieces of information that we would use in this project. So the answer is we pulled as much information as we can locally where available, which was the case with the HDR existing data sets, but then beyond that into Alaska, and then beyond that in the Northwest, et cetera.
All right. Chief, do you have any comments or questions for Dudley?
Well, this area is beyond my level of area of expertise, but thinking about it from the perspective of an embryo or a juvenile fish, I would have to wonder when is my most troublesome time period, and I think it would be winter. And so the natural question is, how good is your data in terms of trying to predict what happens in the winter? Or is it just, well, I'll leave it to you to answer.
Yeah, the winter period, Mary Lou mentioned, there's been some work done on winter habitat conditions, winter sampling conditions. The reality is there's anybody that knows the project area, first of all, has to understand the logistical considerations that are part of the sort of the way that you do work out there, which is all geared towards safety. And so there's the mandate that you go out and you come back the same day. It's not like you go out and camp and set up a base camp and then you can really intensively work. In the wintertime in particular, it becomes difficult just from a safety perspective to go out. You have short daylight. I'm not trying to sidestep the question. The short answer is there's been some work done. but we have not done any detailed analysis related to that. The one exception would be in looking at temperatures. We have explored development of an under ice temperature model. SynTemp is really an open water type model, and so we're exploring development of an under ice model that would allow us to take the effects, the flow, potential flow related effects, and extend that into a period of time when you'd have ice cover. And where that might come into play is if you do change the flow regime, that might affect ice formation, the thickness of the ice, the timing of ice out, breakup, etc., that could have effects on the ecology of the system. So that's being explored. It has not been developed to any degree, but it's something that we're looking at. So I would admit, I think that the wintertime studies, the wintertime periods out there, are something that are important. I've said that before in other venues, other discussions, where I think that's an important part. It could very well be that wintertime conditions are one of the limiting factors of the populations in those areas. Given the severity of the winters, I showed you those intergravel temperatures where it looks like there's freezing going all the way down into the gravel at certain locations. So there's, the wintertime conditions are harsh out there.
That's all I got.
Okay.
I don't want to go out there in the winter either.
All right, Si?
I guess like Jeep might feel a little insecure in this topic. I don't see a tidal signal in your hydrology. So, but I guess follow up a little bit on what Mike said about sort of integrating the challenging morphology and hydrology. I'm sort of used to looking at habitat suitability in tidally influenced systems as a sort of multi-spatial aspect. And I guess I was curious if there is a methodology that carries it to looking at landscape connectivity amongst habitats, particularly when these habitat suitability or the weighted usable area declines in one habitat but allows a node of passage into another habitat, and particularly relative to different life history types that have certain different responses to variability in velocity or other attributes. So is there a methodology that allows you to sort of take a landscape scale view and identify areas that enable fish to adapt to changes, especially rapid changes in hydrology, or something that changes the habitat suitability from one habitat to another, but it still gives them refuge. It still gives them a mechanism to adapt to that, so that you could say these reaches have higher adaptability capacity than others, that then could enable you to classify more than just weighted suitable
Right.
area.
Well, what comes to mind there is an approach, a modeling approach that has been applied in other projects with two-dimensional modeling that's becoming more applied in the in-stream flow environment as well. That gives you spatial coverage, and it gives you the ability to track habitat and how that habitat changes spatially, and how it may blink in here, if this is what you're talking about, blink in here and blink out here, and then as you change flows, maybe it shifts over and the habitat now is available in this location, and now it's not over here, and how it shrinks, etc. And so that type of a method is available. Those types of models are available. We considered those. We've still had discussions with Pebble regarding those. They're a model that is easy to jump on the bandwagon and say, let's do these, because they've got a really visual attractiveness to them, because you can display the results of it and see how these habitats change with flow. If you talk with hydraulic engineers, and in our group of scientists and engineers, we've looked at that. We've looked at the habitat flow relationships that you generate with a 2D model versus a 1D model, and you tend to see the same patterns. In other words, you got to figure out what is it that you're getting, what is it that you're buying that's better with the 2D model than the 1D. One thing that jumps out, just as you're saying, is the spatial coverage and the ability to actually see that habitat and how it changes. Some linkage, I've thought about it, whether there's some linkages that could be made with groundwater, and sort of tying in the surface and groundwater model together is another thing that that might be worth considering, because that aspect of groundwater is very important in these systems. So there might be some value of exploring that as well.
So you might consider re-arguing that.
Re-arguing.
The benefit of switching to that 2D spatial.
Yeah, there could be some benefits, right, exactly. I mean, we're just sort of pointing out some things. And if that were to be done, I think you would do it strategically. It wouldn't be like you'd 2D model the entire North Fork, South Fork, and Upper Tulare, but you could zoom in on certain areas that you point to as being important, and let's get a better handle on that and approach it that way. So that's one possibility.
That's all I have.
Okay. Hal, do you have some comments?
Well, I've got more questions than comments, and they pretty much all have the same form. I have something to say, and then I want to turn and say, did I get that right? I also have to start by saying this is completely out of my area of expertise, and it's always been a very mysterious thing to me, this in-stream flow. But I do really appreciate your explanations, including your written explanations, and I've learned a lot from these presentations. But as I sat down and went through the review, I was trying to think, well, what good is this? And I think that the conclusion I came to, and this is leading to my question, did I get that right? There's two kinds of values here. One is a descriptive value, and you showed us that one graph where you're showing across space these spikes in habitat. And so that, I think that's probably the major value of this. But there's potentially also a predictive value where you could talk about, say, impounding some water or redirecting some water and changing the flow, and then you'd predict what that would do. Have I got that right?
Yes, I would just add one other element to that, which would be the potential effects or the potential impacts. I think you mentioned just understanding what the habitat areas are under natural conditions. One of the abilities then is to evaluate what it might be under different operations. And then the third part of that would be using this type of an approach in understanding or evaluating various mitigation options that could come into play that are flow related.
Well, here's another thing I want to know, did I get that right? So I think the modeling that you're talking about all has to do with surface flow. So, for example, if you dug a big hole and then had to dewater it, you potentially could really change the flow that isn't on the surface. And this modeling would be less valuable. Or could you comment on how valuable would this modeling be for that kind of situation?
Yeah, that is direct link to the groundwater modeling that should have been, hopefully was presented last week in the discussions. And it very much is still relevant. This surface modeling piece that we're working on is very relevant to that, because we will be reliant upon the results and the outputs of what the groundwater modeling says related to a big hole in the ground, and how does that translate downstream to the habitats that we're actually measuring and developing our models on.
But mightn't those habitats change because of the non-surface flow?
Yes, and the models that we're working on are considering that very thing. So when if we get into a situation where right now we're looking at baseline conditions, if we get into a mine scenario, there will be certain watersheds that will be affected by that, and the hydrology that we would be provided, that we would then run through any of the models that we have, will have that factored into it. So it'll cover that loss of drainage area for the hole in the ground, And anything associated with the groundwater that would be resulting from that would also be factored into the output that we would get on the surface habitat flow modeling. So it would be covered. And then as well, the groundwater model will feed in directly to the hydrology. It's interesting when we've worked with the groundwater hydrologists and surface water hydrologists, as I mentioned during the presentation, we can, the different transects, the different habitat types that we're trying to model downstream longitudinally, each one of those has got a signature of surface flow and a particular amount of groundwater that can be calculated based upon the groundwater model. So we rely on the surface hydrologists and the groundwater hydrologists for telling us at that location, how much water do we actually have under different flow conditions. So it's very much useful to, even with the mine, whatever the mine footprint might be, for evaluating what those potential effects would occur to habitat.
Okay, and I got about just 1.5 more questions. So as I was thinking about predictive models, I thought, well, I'll sound like just somebody with a one-trick pony, but if you make some changes to the habitat, what I would be interested in is what's going to be the population level effect of some of these animals in adult equivalency units. And then I thought, well, it's probably hopeless to think about that with these models, but I'll let you comment on that after I get to my next point. Then I started thinking, well, yeah, okay, I've been for decades now involved in these modeling efforts where we do our best, and then once we try it against reality, there's disappointment. And often, statisticians have different ways to predict how much disappointment there'll be, in terms of confidence intervals. And I know we don't want to be descending too deep here into buzzwords. But, there's things like cross-validation and bootstraps and so forth that you can use to try to figure out ahead of time, well, how well is this going to work in reality? But those things can really be tricked if you have the things you're using to predict the future are all clustered somehow. So, for example, if you have clusters of flow and clusters of salmon abundance, that could be tricked. How would you, or you must have thought before now, how you would go about convincing what I might call an open-minded skeptic that these models have predictive values?
Well, you've touched on an element of the work that I might have mentioned right up front in the discussion, which is this age-old quandary that we have of tying in habitat, flow, and fish, trying to come up with some model that's got a predictive element to it. There have been countless attempts at doing that. And there have been some successes, some not so successful attempts at doing that. The reality is when you get into habitat flow modeling, which is what we've done here, you're making the assumption that the habitat that you're modeling is important for fish. How much habitat you provide for any given year, and how it relates to the numbers of fish coming back at that particular year is literally, to me, it's without further evaluations, life cycle modeling, other things that you would bring into the picture, you wouldn't be able to even put forward a educated guess, I guess, as to what that might be, because there's just so many factors that come into play. But that doesn't make the tool that we're dealing with, or what we're talking about right now, any less valuable. We've worked on projects in the state of Idaho quite extensively, and trying to come up with a flow regime on a number of streams for Chinook salmon. And this is a part of water rights. And so you go forward with this with the idea that, knowing that right now in the state of Idaho, you have no resource. I shouldn't say no resource. If anybody's from Idaho here, you're going to be very upset. By comparison to what Alaska has in a lot of their stream systems with salmon, anadromous fish, they're fairly sparse. The numbers of fish are fairly sparse. Does that mean you can't use and shouldn't go forward with some type of a habitat flow quantification to try and estimate what the habitat should be like or what the flow should be like. Even if the fish, are not there yet, you don't know exactly how many you're going to get, but you've got to provide that habitat. That's the key element of what these fish rely on. We know that if you don't have the habitat, the fish are not going to be present. Taking it to that next step and saying, well, this amount of habitat at this flow is going to give you this number of fish is just a very difficult proposition to undertake. Not that it can't be, not that it wouldn't provide some additional information. I know you had in your earlier conversations had asked about, well, what's the contribution? What are the Alaskans faced with here? So that question is looming, and I think it warrants further discussion. As far as how you might integrate and try to address some of those questions. Habitat to me is very important. It remains the key element. And I know from Pebble's perspective, they're interested in a metric, they can monitor over the long term and they can understand how that changes and they want to protect that habitat. So it makes perfect sense in order to approach it this way. But there's also the underlying part of, well, what does that mean? What are you losing? I mentioned what are you potentially losing? I mentioned in my discussion each one of these drainages, just from a surface area perspective, represents about 0.3% of the Bristol Bay watershed. So collectively, we're talking less than 1% of the Bristol Bay watershed. Does that mean they're not important? No. From my perspective, that doesn't mean that at all. It just says, it puts it into a perspective that these are not massive watersheds that we're dealing with, but they're watersheds that are relatively small, but they sit in the Bristol Bay watershed, and they still have a tremendous value to them. And the key is to understand what the habitat, in my perspective, understand what the habitat flow relationships are, understand what the project potential effects are, understand how you might try to mitigate for those, and work at it from the habitat perspective, but also consider, I'm sort of going around and around here, because there is no real pure answer for it. It would be nice if we had that information, but we don't at this point. I'll leave it with that. Did I answer 1.5 questions, or was that more like 2 or 1?
Yeah, I think that you get full credit for 1.5.
All right.
Yeah.
So other questions from any of the panel members for Dudley?